Hi guys, so today we're going to be doing problem number 26 of the USNCO 2020. So we have an irreversible reaction, and it's monitored in a buffered solution. It's a buffered solution, and it's under conditions where B is much greater than A. And we're measuring the concentration of A as a function of time, where B is much greater than A, and the decay of A is found to be first order. And we're given the half-life for its disappearance. Okay, so we want to find the rate law. Well, we know that A is first order, right? And the fact that they told us that the concentration of B is much greater than A is a cue for us to think about something called pseudo-kinetics, right? So when we have two reactants where the consumption of one might affect how we measure the other, right? We don't need to worry about that because B is much greater. So even though it might change a little bit, the changes are negligible, where we can just look at the disappearance of A for what it is in relation to the concentration of B when we deliberately change it, right? And the pH. Okay, so what is the rate law? Well, when we have a table like this, we can sort of see the relationship between the numbers here. So when we have 0.1 molar and it's going to 0.2, right, we're multiplying the concentration of B by 2. So what's going on with the half-life? Well, it's getting multiplied by 1/2. Okay, and one thing we should remember is that half-life is inversely proportional to concentration. So when we have 0.693, or the natural log of 2 over K, is equal to T of 1/2, right? 1 over K times the natural log of 2 is equal to T of 1/2, so maybe that'll help you better see this inverse relationship. Yeah. So B is also first order, and so we can eliminate B and C because here it's showing B as a -1 order. Okay, so what's going on with the H+? Well, we're given pH, and here it's staying constant, but here we're changing it from 1 to 1.5. So what's going on with the concentration of H+ when we're given the pH? Well, if we have a pH of 1.5, then we have an H+ concentration of 10 to the power of -1.5 over 10 to the power of -1, which is equal to, yeah, let me do that. It's going to be equal to 0.316. And if you look at what's going on with half-life, we'll see that it's also Okay, so H+ is in first order. We can eliminate D, and so our answer is going to be